All right, in this video, we're going to look at topic 67, example 1, where we use a graph to solve an equation. And on the right here, I have a online version of the TI-84, so that'll follow along and you can use that, the handheld version if you're in class. So part A, there's telling us to solve negative 3x plus 20 equals 5 by graphing. Now, you could solve this algebraically, but for this section, we're going to work with graphing and how to use the calculator, how to manipulate graphs to find solutions to equations. So an equation is a statement that two expressions are equal. The values of x that make the equation true are the solutions. So sometimes there's multiple solutions, sometimes there's no solution, sometimes there's infinite solutions. Our goal here is just to figure out for these specific problems what the solutions are. So to solve an equation by graphing, you're going to write two new equations by setting y equal to each side of the original equation. So what you want to do is you want to take your original equation of negative 3x plus 20 equals 5, and you're going to set y equal to negative 3x plus 20 and y equal to 5. So all you're doing is you're taking the left side equal to y and the right side equal to y. And then what you can do with those is you're going to plug those into the graphing calculator. So as I click the buttons on the graphing calculator, you'll notice that they highlight in red. So I'll hold them for a second so you can figure out where they are. But the first thing you want to do is you want to hit this y equals button, and that'll bring you here where you can enter equations. So we're going to type in negative 3x plus 20 for our first one. The x key is the one next to the green alpha key. So this it looks like xt, and then you have your symbols. So you'd hit that. Don't use the actual alpha key and type the letter x in. You want to make sure you use that button. So negative 3x plus 20, and then I'll scroll down and type in y equals 5. So the handheld calculators obviously don't have the color functions, they're just going to be in black and white, but the idea is the same. So once you've typed those two in, you would then want to hit this graph button in the top right. The calculator, again, the handheld ones will be a little bit slower, but that's the general idea. So what we have here is y equals 5 is going to cross somewhere around here, right? If we were to draw a sketch of this, so if we graph the two equations, identify the points of intersection, these points will have x values that produce the same y values for both expressions. Each of the x values is a solution to the original equation. And then this second one, so it's kind of tough to see, on your graphing calculator, but what's going to happen is 1, 2, 3, 4, 5, 6. So right before 7 is like an x-intercept, and it looks like it crosses 5 at it crosses the 5 at 1, 2, 3, 4, 5. It's not always the easiest to see this, but you'll make it work. So it's going to cross somewhere like this, and as this lesson goes on in later videos, we'll spend a little bit more time on the graphing calculators and how to find the specific point where those two lines intersect. Right now, we're just, take my word for it, those 2 points are going to intersect at 5, 5. The solution to your equation is the x value of where they intersect. So they intersect at 5, 5. The solution to negative 3x plus 20 equals 5 is the x value. So we care about this right here. So my solution would be x is equal to 5. And you can test that out by plugging it back into the original equation. So if I were to do negative 3 times 5 plus 20, and I want to see does that equal 5, well, I get negative 15 plus 20, and then I'll get 5 equals 5, which checks out. Right, so anytime you're doing this, obviously you might want to check your answers to make sure that they work. But again, in later videos, we will go over exactly how to find the intersection point on the graphing calculator, rather than just kind of eyeballing it right now and hoping for the best. In part B, they're asking us kind of the same thing. They want us to solve an equation by graphing, but this time we have an absolute value and a fraction. So I want to do the same thing. I want to show you how to enter this type of equation into the calculator. So you're going to hit the clear button, right? Everything will go back to the original spot. But for this one, our two equations, we want to do y equals the absolute value of x minus 4, so that left side. And then we want to do y equals 1/2 x plus 1. So we do want to be careful with how we enter these in the calculator, but you're going to hit that y equals button again, let's clear out what we already have typed in there. And now I'm going to go to, nope, it's not letting me work on, it's not letting me enter anything on Y1. So we'll just enter as Y2 and Y3. But idea is the same. To get the absolute value symbol, you're going to hit this math button on the left side here. So right under the alpha key, that math key, it'll bring you up to this screen, and then you want to hit right, and that'll bring you to the number section. And number 1, ABS with that parenthesis, that's the absolute value. So you can either hit the 1 key, which will select option 1, or since it's highlighted, you can hit enter. And now we have our absolute value bars. So I'm going to type in x minus 4, and then I'll go down to my y3. Again, you can enter these as y2, y3, anything will work. For some reason, we're just having some trouble with y1 here. But y3 will be 1/2 x plus 1. Anytime I enter a fraction, I like to put that fraction in parentheses. So I'm going to do parentheses 1 divided by 2, close those parentheses. I missed the 1 button. So 1 divided by 2, and then hit my variable key, x plus 1. All right, so now when I hit graph, if I graph this, we get an error. So let's figure out what that error is. We gotta turn the plot back on. That's probably why. All right, there we go. So when we graph this, this is what we get. Now again, we kind of have to eyeball it here. This isn't the most functional thing we're looking at, or the easiest thing to look at. But we have something 1, 2, 3, 4. So my graph, my absolute value is going to be somewhere around 4. And I could pick a couple other points. I know that this graph is going to intersect at 10, 10. So I'm just going to put that point there to make my life easier. Again, just take kind of my word for it right now. That's where it's going to be. So we'll draw that line there. And then we'd have the same thing. That graph is going to go somewhere. So 8, 10, 6. It's going to go somewhere like that. All right, looks like it has a y-intercept of about 4. I was a little off there, but close enough. We'll deal with it. We'll fix it if we have to. And then my second equation, the 1/2 x plus 1, I can graph that by hand. I know I have a y-intercept of 1, and if I go up 1 over 2, so we're going to have to fix this. This is not going to work for us. We want to get the actual right solution. So let's plot that. We go up 1 over 2. 1, 2. Up 1 over 2. And then this will give us a little bit of a better sketch here. It's just not working out well right now. So let's go there. There we go. That's a little bit better. There you go. Hopefully you're learning from the mistakes here and realizing that not everything always works out very nicely on the first try. So the absolute value one, let's go back to that. We know that we have the 0.40. You can always plot these by hand. It's a little bit of a pain, but for our purposes, that's what we're looking to do right now. And I'm sorry, I said 10, 10 before. It was actually 10, 6. That's why my graph was off. So it crosses at 10, 6. That makes a whole lot more sense. That makes my graph match up a bit better. It is tough to see here. I'm going to redo that one because it's supposed to cross right at 2. So it'll cross somewhere here. There we go. All right, so now hopefully you're still with me. But our 2 intersection points, we actually have 2 of them, are here. So we have the point 2, 2, and we also have 10, 6. All right, so using that 2 and that 10, my x values, right, those are my solutions. So whenever we're looking for the solutions, remember it's where it intersects, and we're looking for the x values. So x equals 2 and x equals 10. A bit of a pain when you're looking at the graph trying to figure it out just, again, by eyeballing it, but in example 2, 3, and 4, I'll show you some other features on the calculator so you'll be able to find the exact intersection points without having to kind of guess and check. All right, the fortunate thing, I knew the answer for part B because I already had it written down, so I knew what the graph should be. But the idea here is make sure you know how to plot these and place them into the calculator. All right, but just to simple review, take 10 seconds. Anytime you have an equation, you can set the left side equal to y, the right side equal to y, type them into the calculator, graph them, and then find the intersection points and use the x values. Those will be your solutions. So again, thanks for bearing with sticking with me through the technical difficulties, but we found our answers.